Hello, I'm Roberto, and we are back to learning Rust. Here with us, like always, Luciano, on
Hello.
my left, right, up, down, somewhere. And if you don't know this channel, in this channel we talk about Rust and technologies. You can find recordings of previous streams on YouTube. And if you're watching this on YouTube, we stream every Monday, almost every Monday, 6 p.m. Dublin time on Twitch. Today we are going to start a new CodeCrafter uh, experiment, task, project,
Mhm.
something that will be our own small Kafka written in Rust. If you remember that we already did this kind of stuff with CodeCrafter, with other stuff like BitTorrent, DNS, and so on. So today we are starting to do the Kafka one. Let's see how it goes. We
And
already did the Luciano, the first step, that is the setup of the repository.
yeah,
And now we are a little bit back to do something for real.
and if you don't know CodeCrafters, I'll be sharing my screen in a second. So let me do that. You should see my screen. So it's basically a website where you can exercise your skills with a particular programming language, but rather than just doing, I don't know, hello world type of things or relatively simple or more or less complicated coding challenges like one-off type of coding challenge where you need to do stuff with arrays or reverse linked
Reverse a linked
list,
list.
that kind of
Yeah.
stuff. Here you get to build more or less realistic reproductions of real software like SQLite, Torrent, Redis, whatever. So we picked the Kafka one, which seems interesting enough to do in Redis. Sorry, in Rust. I'm tired today in Rust. So
We are all tired.
we'll start to look into it. So there are a few steps that every code crafter exercise has, which is effectively you clone a repo. Then with that repo, you are basically able to write some code and get some tests to check that your partial solution is correct. And then basically exercise after exercise, you keep building the specific solution. And every time you do a step, effectively you have a tool to test and a tool to submit your solution. So the first three steps are literally just setting things up. The real first step is bind to a port, but they already give you all the code, which we'll see in a second.
Yeah.
You just need to uncomment it, test it, and submit it. So if we look at the current code, it looks like this. So literally we only have a main, and in this main, there is nothing than creating a TCP listener, bind it to a port, and then we listen for incoming connection. And then for every connection, we just print accepted new connection, or if we fail, the error. That's it. That's all we did so far. And we didn't
Oh,
even
now
write
we
this
have to do.
code. This is literally coming from the template the code crafters give you.
Yeah, now we have to do something for real.
So let's see what it is.
What is
So
our task if we accept this mission?
okay, so in this stage, you'll send a response with a correlation ID. Response message. Kafka brokers communicate with clients through the Kafka wire protocol, which we'll probably need to study because I have no idea what that looks like. The protocol
Um,
uses a request response model where the client sends a request message and the broker replies with a response message. A Kafka response message has three parts: message sides, header, and body. For this stage, you can ignore the body and just focus on message sides and the header. You'll learn about response bodies in a later stage. So the message size field is a 32-bit signed integer. It specifies the size of the header and body. For this stage, the tester will only assert that your message size field is 4 bytes long. Okay. It won't check the value. You'll implement the current message size value in a later stage. So we can pass any random number as
okay,
long
so
as it.
just a 32-bit integer. Cool.
Mhm.
We can do that.
Can you hear any background noise coming from me?
Yeah,
Okay.
yeah.
There is the ice cream van because
Oh,
whatever.
yeah. It's ice cream time. Cool. No, yeah, I
Ice
was
cream time.
passing last year, but this year I didn't started yet. It's too cold. I'm norther.
Yeah. Anyway, um,
Header.
Header, Kafka has a few different header versions. The way Kafka determines which header version to use is a bit complicated. Ooh. And it's outside the scope of this challenge. For more information, take a look at this thing and this Stack Overflow answer. That's amazing when a Stack Overflow answer becomes kind of a official doc.
Documentation. Yeah.
In this
Until they
state,
don't bring down Stack Overflow, you mean?
exactly. Then I don't know. Not even AI will be able to help us.
Yeah.
In this stage, you will use the response header v0. Scroll down. So we'll figure out what that is. Response header v0 contains a single field called correlation ID. This field lets client match responses to their original request. Here is how it works. The client generates a correlation ID. The client sends a request that includes the correlation ID. The broker sends a response that includes the same correlation ID. The client receives the response and matches the correlation ID to the original request. The correlation ID field is a 32-bit signed integer. For this stage, your program must respond with an hard-coded correlation ID of 7.
Okay, so we don't even need to read the packet that is coming through. We just have to send out message size, any value, and the correlation ID 7.
That's my understanding as well. So the tester will execute your program like this, dot your program.sh. It will
using netcat to send a request to localhost on port 992, and is using xdump to see the answer. So we need to send back that, so 8 bytes, when we have a packet on that port. And all the integers are big endian.
Yep, pretty much.
Okay,
Okay.
we did this with DNS last time, but I don't remember anything.
Yeah, same here because it was a long time ago. But basically, if we copy all of this, right? If we want to do a shitty solution, what we can do,
We can take the stream and do a send over the stream.
how do we send right? I think.
Yeah, right, but there was something about big endian and little endian.
Yes, what I'm thinking is literally just doing this and see what happens. Why did you do all of this? Okay, so literally if we do this and
Then you won't wrap because it can fail.
is that enough? Oh, it wants a reference.
And is happy with the 07 or just wants 7?
Cannot borrow stream. Right, can we do mute?
Complaining that.
Written amount is not handled.
Write
Use
all.
write all. Okay, fair enough. And
That's
7
07.
just wants, I guess, 7.
Yeah, the double 0
Although,
is fine for it.
yeah, this is, how do we specify that this is x values? 0x?
But well, 7 and 0x7 is 7.
It's the
It's
same,
no
yeah.
different. Yeah,
Fair
and zeros
enough.
are zeros.
Yeah.
They are
So
all
can we
U8.
just, I don't know
Yeah.
why he's happy with the double 0 and not
Maybe he's
7.
taking that as an octal, but even 07 is a valid octal. Yeah, in theory, yes. But well, who knows? Okay, try to
Okay.
run the program and run that
What
command
we
line, and
can
we'll
do
see what.
just to be sure is 0x0. And now if we run the program, let's go back. Where is my terminal? So we can split. You cannot
What
split
do you
up.
want to split? Split Jellies or split down?
Down. Yes,
I mean,
makes
is
sense.
the same.
It's the same thing. Yeah, fair enough. I told you untired. So we can run the program here with
Please, somebody send $5 for a coffee for Luciano.
exact. So this is gonna compile until forever. Meanwhile, I can copy paste this.
Do you have netcat and xdump? Or
I
do
hope
you have
so.
to brew install it? Okay, you have netcat.
Yep.
Oh, you have everything.
So
Good.
place all the request. What happens there? Interesting.
Seems fine, only that is not on. Yeah, is on a single line, but who cares?
Mm-hmm.
Okay. Do you want to do a CodeCrafter test to see what it thinks? Remember that CodeCrafters gives you a CLI. Through this CLI, okay, what is this? I don't know.
I enable PGP signing on Git.
Oh, for your commits.
Mm-hmm.
You are so fancy. I hope this works with CodeCrafters. Test
It
passed.
did work.
Okay, I was saying that CodeCrafter gives you his own CLI. The CLI is used to run the test locally. I think they run remotely in reality, but they run with your local code on the remote CodeCrafter test servers, and then you can submit, like Luciano did now. And at this point, you should see on the web page if everything went well.
I did not submit. I just
Oh,
tested.
sorry.
Let's
Now
see.
Luciano submitted. That will create the commit, push the commit, so you can run this with the CLI or with GitHub, with Git, like a normal
Mm-hmm.
repository. It will trigger anyway the tests remotely, and on the web page we should see that this step is done, and we
So
should see
if
that
we go there, yeah,
yeah,
mark stage as complete.
yeah. Now we can mark the stage as complete and move to the next one.
How did we do?
Oh,
Okay,
fine.
cool. So next step.
Oh, parse the correlation ID.
From the request. So we'll need
Yeah.
to read from the request.
Mm-hmm.
So to get the correlation ID field, you'll need to find its offset. You already know that message size is 4 bytes. And it is what the request header looks like. In this stage, we're using request header v2. So there is a request API key, request API version, correlation ID, client ID, tag buffer. What the hell is that? I don't know.
It's a compact array. Oh God, now we
And
have
also,
strange types.
what is a nullable string? How do they encode that?
Annullable string, I hope is a zero terminated string, like in C, I hope.
We'll find
Maybe?
out.
We'll find out, yeah.
Okay, to learn more about the different data types, should we look into that?
Now let's look at the rest of the text, then we jump to the protocol primitives.
Okay, so the
So here is
example
an
is
example.
message size, the first 4 bytes, request API key, which is also interesting.
18. Okay. It's an int
Yeah,
16, so
why? I was expecting this to be like a string or something.
we'll find out.
So you could technically brute force.
But maybe this is just a pointer to. But we'll see. I don't know.
Okay. Request API version is, yeah, the version as an int32. No,
I don't
sorry, int
think they.
16. Yeah, that makes more sense. And this is the correlation ID, which is int32,
Okay.
right?
Then there is after that there is the client ID, the tag buffer, but I don't think we need to parse it
Mm-hmm.
for now. So doing that, what is x60? Go down in that command line with echo. There is a pipe to x6d. Do you know what it is?
Probably another xdump. No, because they're doing xdump there.
Probably is doing from ASCII to
Oh,
binary
yeah.
because you can't write binary in the terminal. Then it's
Do
making
I
it
have to?
binary and is piping it into netcat.
I'm just curious. Yeah, I
Yeah,
do have
you have it.
XFD. Interesting.
And if you saw that is yeah, a bunch of bytes. Cool. Now, do we
Okay.
want to declare a type to map that stuff? Even if we just need up to the correlation ID, and I think for now we can not care about what's
Mhm.
after it. So we can start defining the
So
type
what do we call it? Kafka message?
request. Oh, well,
Or let's just call it the request.
Kafka request. I don't know if request goes
Mhm.
is shadowing anything else.
So we have a few things.
We have the message size as a 32-bit big endian.
Wait, this struct, do we want to keep it clean? Just keep the data we care about and then create like a deserializer? How do you want to do it? Because I guess this length here, this message size only matters for deserialization. It's not something you probably want to keep around.
Let's just start keeping it. Then we can change the data type later on when we have the need
Okay.
for it.
So we'll
So we can
basically
start.
have message size,
Yeah,
which is a U32, was it?
yeah. When you serialize and deserialize it, what we think to use to do the serialization and deserialization from the stream buffer, or we do stream read U32 big endian, and
Yeah,
we
that's
can
what I was
create
thinking. And then we create an arbitrary
a from
vector.
iter. We can create a from. We can implement a from stream for that type that you are writing.
Yeah, basically what I was thinking was something like this. I'll do some
Hmm.
pseudocode, headers,
Yeah.
and body with whatever type makes sense,
Hmm.
and then implement from vec u8
Ah,
for
okay.
request, and then basically we'll need to read the first 4 bytes, then read whatever is that length, and then create the vec u8 and turn it into a request.
And pass it. Okay, got it. Let's do that.
Now
The
I
body and header, do you want to create a couple of
can we
types, or
do
because we
like
don't know them
this?
yet?
Does that work as well? Yeah, okay. So this will be a little bit more generic. Can be any slice of UI.
We don't know what is the body yet, and maybe we don't need all the headers yet. So
What I was thinking is, yeah, we can add that later, and headers we have. Let's just call it rec for simplicity. Well, we'll need to rewrite this one, but headers can be another struct. Why Copilot? You are guessing stuff
Copilot is
that
inventing,
doesn't
I
make
don't know
any
what.
sense. A new protocol.
No, no, that makes no sense at all.
So we have request API key, which is a U16.
16.
Then request API
Request
version.
API version, another U16. The correlation ID is U32.
Copilot, please. Correlation ID.
Oh,
Why?
maybe it started understanding why is called the request API key. Call or it only API key?
Yeah.
No, because it's called the request API. Okay, cool, cool. Don't mind me.
No, but it doesn't make any sense, right? That these two have
No,
requests.
let's keep it. Let's
But
keep
whatever.
it. Yeah, yeah.
Okay, the other two we ignore for now, right? So
We can ignore them for
we
now.
will have
Yeah.
a client ID and we will have a is a request key? No, tag buffer.
No, it's a
Whatever.
tag buffer.
Okay, so assuming that we already have the correct length here, right?
We get what an array, a reference to an array of U8, right?
Yes, here.
We only care about the first 64 of them.
Exactly.
So the array can be longer. I just don't care. What is Copilot suggesting there?
Doesn't seem too bad.
BE stands for big endian, right?
I think so, yeah.
Okay, and in the documentation was saying that those are big endians, correct?
I remember that is big endian, yes.
Okay, I think this is enough. It will panic if we don't send at least 8 bytes, correct?
If we don't send, yes, 8 bytes. Yeah. As soon as you try to access stuff that doesn't exist. Yeah.
In theory, that could happen, but
Yeah, if we
let's
want
not
to make
care
this a
about
little
that
bit
for
better, we
now.
could do like a try from. Let's just say turn this into a try from. Right, this could be an improvement for the future.
Okay. So now
So,
what you want to do here? You want to read the message length from the
mhm.
stream.
So read message length. So basically, the message length is 4 bytes, right?
4 bytes, yes.
Perfect. Perfect. Right? Makes
There
sense so
is
far?
not on the stream something like read. Show me the read methods on the stream. I was remembering when we did the DNS one that there were some fancier one. No, there was not a read U32 big endian method.
Not that I
No.
remember. Maybe we created it.
Okay. Okay, cool.
So that makes sense. And now what we want to read is
8 bytes, so we can create another buffer of length 8.
but this time needs to be a vec because it's a dynamic thing, right?
But we care only about the first 8. But you want to read all the packet. Okay, yeah. Of length len, yes.
Okay. And then yes, that was making sense. And
So
now at
this,
this point we have rec.
if we don't read the right amount of bytes, this will crash in line
What does it
44.
do read exact? Does it just time out or does it hang forever?
There is an unwrap, so in theory that should throw an error if there is not enough data on the stream.
Oh, no method name read exact. Do we need to import a trait?
Wait, read is
Yeah, we need to
implemented.
use this guy. Like we have IO, right? We need read
Okay,
as
we need
well.
also your read. Okay.
Okay, and now request from. Wait. Okay.
Okay. Now going back to the instructions, what do we have to do with this? Just send back the correlation ID.
Good point. I don't remember. So we need to respond with. Where is it?
Okay,
Yeah,
so
zero
we
zero
have
zero
to
zero and correlation ID. So whatever we
and
did that was 7 here.
yeah,
This 7 becomes the correlation ID. Well,
yes.
this 2,
No,
right?
is a 32
So this
bit.
4.
So the last 4, yeah.
Okay, so what's the easiest way to do this now? Like ideally we needed like a response type and be able
Yeah,
to
we should
convert that to. Do
do
we
a
want to do that?
yeah, let's start with a resp, struct resp with the message length this time.
Also, this one is not something
For
we
now,
care
we have
about, right?
message length and correlation ID. Just add those 2 fields.
Mm-hmm.
and both of them are U32. That's
No,
not
but what I
OEM
was
anymore.
thinking is the following: doing something similar. Struct resp headers, and right now we only have correlation ID, right?
Yeah,
And
but
then
we
we
also need
implement.
but the response also has the message length. This time you can't avoid to add it.
But the message length here is still 0, so we can still avoid it, right?
You want to hard code it for now?
But eventually it's something that we should be able to calculate based on the data in this
Mm-hmm. Yeah.
struct, right?
Okay.
Okay, so implement. Oh, now we have to implement into, is it? I think so.
2 bytes. It was suggesting to implement 2 bytes, but
I have no idea what 2 bytes is. Oh yeah, I think there is a crate. Oh no, this is just a plain thing. It doesn't
it's just
use
applying
any
things
trait.
without using any trait. Can be a point to start.
Fair enough. Why not?
2 big endian bytes is the core of this in line 40, at the end of line 40.
Does that look correct? It doesn't, because we need to add the length first, right?
If you want to also send
Like
the
we need
length,
to add this, then that's correct, is it?
yeah, but then we have to compute those zeros. Okay.
Well, for now we don't, but yes, we
For
will
now we
need to.
don't, yeah, but in future we'll need. Okay, so now we have the buffer. This is a vec of 8, and we can send. Can we send it with a write all?
I think so. So now what we do is let resp or res. No, we call it resp. So let's be consistent. And that is correct. Headers, response header, correlation ID is the same. And now what we want to do is write all, and we say this, and we say resp 2 bytes. Is that happy enough?
Problem with borrowing? No, everything is fine.
Yeah, I think that should be fine. Okay, so
Okay.
now do we do a test?
Yeah.
Or actually, let's run it in the CLI first. So this
You
was
have
the
to run it again.
let's rerun the client,
Program, but
which is complaining that, of
a
course, we have
couple of
stuff
things are
that we're
just
not using.
fine.
And then we
Take
have
out,
this command.
yeah, all of it.
Wait, without the dollar.
Yeah,
Oh,
but
okay. Does that look correct?
no. Oh yeah. Oh, sorry. It looks correct.
What was it saying here? 0000 6F 7F.
Yeah, sorry. I just saw the second line empty and I forgot that is only on one line, your machine.
Yeah.
Now try a CodeCrafter test just to be sure that also the test is passing, and then we can submit.
This is just the address, right? So there is like an empty
That
line.
that is the address of the next byte, but there is no next
Mhm.
byte, so we have 8 bytes.
Okay, so let's run the test. What happened? GPG failed to sign the data. Why you didn't ask me again for the...
Don't know.
Okay,
Okay.
congrats. Submit. Nice.
What
Okay.
we have to do next?
This time I'm not gonna tell them anything.
Yeah.
So in this stage, you need to replace the hard-coded correlation ID. That's what we did, right? Next stage.
Yeah, you forgot to click view next stage. Now we have to parse the API version.
Okay, let me expand here. You need to pass the request API version field in the request header and respond with an error code if the version is invalid. Every Kafka request is an API call. The Kafka protocol defines over 70 different APIs, all of which do
Nice.
different things. Here are some examples: produce, writes events to partitions, create topics, creates new topics, API versions, returns the broker supported API versions.
So instead of having a string to define what you want to do, they have an integer.
So that's what API key means. Now this makes a little bit
This
more
is
sense, but not too
API
much.
version, not API key.
Or
A Kafka
API
request
code, I
specify the
guess.
API. Ah, no, yeah, the API key header is what API you are calling.
Yeah.
Okay. So that is, I want to do a create a topic. That is 22, and that is the API key. Okay.
Yes. Not the kind of API key I was expecting, but now it makes more sense
No,
that you have
yeah, makes more
two
sense than
bytes.
16 bytes, 16 bits, but still, yeah, is strange, at least. Probably
Okay.
they pay bytes in when they did Kafka, they were paying by bytes.
Maybe. I don't know. Maybe
Okay,
they
anyway.
wanted to be extremely efficient and then they brought it in Java. Haha.
Yeah, so the two stuff together, if you ask me, doesn't make a lot of sense, but that's gone.
Okay, sorry to all the Java lovers out there.
There are still some Java lovers.
I think there are. Okay, the schemas for the request and response are determined by the API being called. For example, are some of the fields that produce requests body contains. Ooh, okay, so probably we would have like a big enum on our side for all the API
Maybe.
methods.
Yeah.
The name of the topic, the key of the partition, the event data to write. On the other end, the produce response body contains response code for each event. Mhm.
Each API support multiple versions. Okay, so it's API and version of the API.
Okay. Wow, there is a version 4 that is unreleased. I'm trying to figure out what we have to do. I don't know if I want to
Yeah.
read all of this.
You only need to add support for error code 35, unsupported version. This error code occurs when the version of API versions request by the client is not supported by the broker. Assume that your broker only supports version 0 to 4.
Okay,
Okay?
so what do we need to do? We need to read the version,
Yeah,
right?
that is, we are already reading it.
Mm-hmm. So we just need to return an error. What does the error look like?
If you scroll down, the error is like just another int. Error code 35 is another U16.
Okay, so basically what we
Only
need to do,
only if the version is not between 0 and 4. And if the version is between 0 and 4, what we have to do?
did it say that?
By fit saying that, I missed it.
Probably we keep the code the same. For now, we just return the correlation ID.
Ah, okay.
That's what
Okay.
I can guess, but it's a guess.
So it's an optional field that we have to return. How will you do an optional field?
Let's see what's a good way of doing this. So we already
In
have
our response, we
we
already have
have
the
this,
request.
right?
Yeah, that is fine. Now we have to
So
use it.
here in is it a header now
It's
in
still
the
in the header, I
response?
think. I think it's still in the
Okay,
header
so let's do an error code.
code. But
Now,
that error code is optional.
Yeah, is it optional or is it 0 if everything is fine? Is there a list of error
Uh,
codes?
oh,
Error codes chart. Let's look into that. 0, none.
0, known. Okay. Instead, what we have to send out is 25. No, what was?
What was it? Where
Well,
is it? 35,
30, not
which
20.
is 35 unsupported version. Makes sense.
Okay.
So let's do here. Look at that. Also understands that it's 35.
Magic.
Lots of people have been doing this.
Yeah, I think so. So we have to set error code to 0, and if he's outside of the range 4 to 0 to 4, we have to. Yeah.
Okay, so wait, we need to add that, right?
We have to choose if extending with the error or with the okay, basically.
Well, for now, whatever that is in the response header, right?
It should be
So
35 if
self
the version is wrong.
headers that, right?
Well, yeah, you're
At
right.
this point, this is generic. So whatever is the error code here,
Yeah,
whether it's
you're
0 or
right.
something else, we just dump it in
Yeah.
the byte version. Now here is where we need to decide. So let r no.
Yeah, in case 0 to 4, so it's no error. That match is almost correct, but it's
Actually,
not
yeah.
0.
Can we
Is
do
0 dot
this?
equal 4. Is 4 included?
I guess so.
I think it was
Let's see.
included.
Supports version 0 to 4, so I imagine is included.
I
4.
imagine it's included, yeah.
Okay, so at this point, what we can say is
This.
actually, let's just call it error code. And why doesn't like? Okay, now it's happy. Cool. Do we test this?
Yes.
Do we just do CodeCrafters test? Do we feel brave enough?
Yes, even if maybe it's not working, but cool.
Yeah, it's working.
It's working. Okay, submit. So we always have to send out the error to 0. So it's not optional, it's just 0.
Which makes sense, I suppose, because it keeps the
Yeah,
format simpler.
from a binary point of view, a binary protocol is simpler this way.
Otherwise, you will need to have a way to specify whether there is an error or not, right? In the binary format.
Yeah, you need to. Yeah, it's a mess. You need to have a
Okay,
mask of the available fields, so it's better to just avoid it.
we try to do one more.
Yeah, I think we have time.
Okay, so next step. So in this stage, you'll implement the response body for the API versions request. Ooh, we are still working on instruction for this stage. Interesting. You can find notes on how the tester works below. In the meantime, please use this link to ask questions in the forum. CodeCrafters.
Right?
What's going on? So what do we need to do here? The tester will execute your program like this. It will then connect to the server. The tester will validate that the first 4 bytes of your response, the message length, are valid. So do we need to add the length?
We need to
Or
compute the length, I think, at this point. When we
you'll
send
implement
out.
the response body for the API versions request. So we need to implement the entire spec for API versions.
All of them? Oh, there's a lot of work. Try to scroll down. The first 4 bytes, they should be valid. The correlation ID must match. Okay. Error code is 0. Cool. The response body contains at least one entry for the API key 18 API versions. The max versions for the API key 18 is at least 4. The tester will always send your v4 of the API version request. Okay.
Wow, there is a link to the Kafka source code mentioning this.
If extra bytes are remaining after decoding all the fields of the request body, this will be considered an error.
Okay. So I think we need to go and check the docs. So let's go.
Well, I think we need to implement the message length, and then we have to see what API version, that is API key 18, does.
Exactly. That's what I was trying to look for. So this API version, what is the specification? I think there was a
Yeah.
link here somewhere. Request API key header field. So let's see. Is that the one we had already opened before? No, that was the errors.
No, those are the errors. 18. These are
This
the
is still
errors
error
again.
codes. Yeah, there we go.
Okay,
API keys.
If you go to 18 API version. So now the client is asking us, hello Kafka, what are the API version that you support? And we have to answer, oh, look, we support from 0 to 4. Something like that, maybe.
So API version.
Oh, version 4
Oh,
is
these
version
are the
0.
different versions of Kafka. Okay, version 0, version 1,
Enough.
version 2. Where is version 4?
Version 3 is there, but they told us that they will only implement call us with version 4. So we have to implement version 4, basically. 18.4. We have to implement
Oh, there it
call
is.
18 version 4.
So there is a compact string and compact string that.
There is also a client software
there it
name,
is, yeah.
client software version, tag buffer. I have to say, okay. Client software name, the name of the client software version, the version of the client, tagged, underline fields, the tagged fields that is of type tag buffer that contains two keys, one client software name. No, sorry, client software name. It's not very clear, guys, here. Eh?
No, it's not.
So we have two compact string and a tag buffer.
I honestly don't know if we care about this. Do we?
And we have to send them back. So yes,
No, this is. I think this is just the request. Then what we need to send back is here, which we probably care anyway. Well, actually, this is version 0, so let's find v4. Jesus, there you go. v4.
Error
Throttle
code
time.
that will
tag
be
buff.
0. Error code is an int 16. API keys, that is between square brackets, so I don't know what it means. It means that is a sub-object if it's between square brackets.
Oh, yeah, this one.
Yeah, we have to send error code, the API keys, the throttle milliseconds, and tag buffer. Error code is a int 16. API keys is an object made of API key, int 16, min version and max version. And here we have to send 0 and 4. And max throttle time millisecond int 32, I have no idea what it is. No, I got
Probably
what we have to
explained here.
I got what we have to send back. We have to send back basically a int 16, an int 16, another int 16, a fourth int 16, and an int 32. In the end, there are 4 objects that we have to send back. And maybe we can not give a fuck about the tag buffer. Maybe. The duration in milliseconds for which the request was throttled to a quota or 0 if the request did not 0. Fine.
Oh, I see. Okay. So tag buffer is probably a way to do like an enum where you can specify different types
Yeah,
of
tag
responses.
buffer, I think we have to study the protocol a little bit before going on. Maybe for next time, this one. Or do you want to try to work code something dirty to see if it works?
No, let's try to make it work with the minimum amount of code. But yeah, I'm not 100% clear, so let's review the request. So the request, we don't care about reading any of this because we're not
No, I
going to
think
use it.
we are already reading everything into a vector, right? And we
Mhm.
don't care about what's left. We have to do a match, and if the API keys, the API version, sorry, the API key is 18 and the version is 4,
Mhm.
we have to send back the response. And from what I see, the error code is already part of the body, is not part of the header, if I'm not getting it wrong.
How do you distinguish between the header and the body?
You see that the API version response starts with error code.
Right. So you are assuming that there are no headers, that or that the headers are always the same.
Yeah, not sure. In the end, is a list of is a sequence of bytes from what I care.
Mm-hmm. Yeah, I'm just worried that maybe it expects headers that we are not passing.
It will fail, and we'll find out.
Okay,
I'm more worried of that tag buffer stuff that I don't get what it is.
we can check quickly. There was another link with the types somewhere. This one, protocol primitive types.
Yeah, that one.
Where did it open? Here. So Boolean, we don't care. Compact
Okay, compact
string.
string represent a unique sequence. First, the length n+1 is given as an unsigned variant, and bytes following are the UTF-8 encoding. Okay, what is an unsigned variant?
There is a variant here.
Oh, it's using the zigzag encoding. Damn it.
I don't even know what that is.
Um, Basically, zigzag encoding is saying, do you want to represent -1? You don't have to. If your number is to represent minus numbers in binary, for
Mm-hmm.
example, -1 is all ones for the length of your integer. This is a 32-bit integers. You have 32 ones. That is -1. Zigzag
Mm-hmm.
encoding say, no, I don't know the length of my integer. Is used
Mm-hmm.
to have a dynamic length of integers. So I will do this. I start from 0. 1 is 1. 2 is -1. Then 3 is 2. 4 is -2. 5 becomes 3. 6 becomes
I see. Yeah.
-3. And you zigzag between integers and negatives. So to get the real integer, for a zigzag encoding, you divide by 2. And then if the first bit is 0 or 1, it's negative or positive. Yes, something like that.
Mm-hmm.
Okay.
That's I don't know if there is a crate or something to do that, but
Or we can divide by 2. But this is an unsigned variant, so unsigned makes the zigzag useless. Encoding from the variable length zigzag encoding. Okay, this is even different. Um,
and also why then it needs to be unsigned.
I think they are talking about ULAB 128.
Is
Uh,
there an example of this, like a definition? It's not even defined here.
no, it's probably in the Google protocol that they put a link to. The Google encoding, the Google protocol buffer, protobuf.
Okay.
Try to search for ULab 128.
With a space.
No,
No.
would be like that. I decoded this for the place I work to because I was decoding proto buffer messages from Kafka manually.
Okay.
So I did this. I hope there is a crate because it's annoying to decode them. I have some Python code for it. But
Fair
anyway,
enough.
we
Okay.
start. Go back to the types. I was more curious about the
What was it? The
tags. How it was called?
I even forgot. Was there the no? Sorry, we were looking at too many links. Where is the protocol thingy? Tag buffer. So what is a tag buffer? Is it even explained? So these are primitive types. So probably it's not here. I didn't see it here at least. Let's go ahead. Error codes. Let me
Try
search
to
for
search
tag.
tag buffer.
Oh, this is like one giant page.
Oh,
Jesus,
thank you.
697 occurrences. And the first one is just randomly in the place where we were looking at it. Not useful.
No, not very useful. Cool.
Let's use Google. Is this what we were looking at? Yeah, that's the same page.
Okay.
Is it maybe in the so protocol primitive types? Okay, so this wants to be like a grammar type of thing.
Yeah, the message size is the first one. Then is defined all the constants. We can try to define our body. How is the body of that request 18 version 4, and then try to serialize it and see if it's enough without taking care of the tag buffer. Just ignore it. And if we get an error, it means that we have to find out how to add the tag buffer, even a null one.
Yeah, let's do that and
So the
hopefully.
body, in this way, modeling the type in Rust is like an interface basically. So the body can be, in this case, a body is made like this. So error
Mhm.
code that is in the header for us, so we can leave it there. And then there is 1, 2, 3, int 16, and an int 32.
Yes.
So we can create a body that is API version response body, but for now we can just say that the message has that one. But then we need an interface, and we need multiple struct that implement the same interface. Or a union, I don't know, in our response object. Obviously, that will be a union of, I don't know how many APIs are there.
Something like 70, I think they said.
70. Okay, so it's a union of 70 types, or there is a better way of doing that in Rust?
I guess it depends on how much type safety you want. But like, yeah, if you want more type safety, probably an enum. You
Oh,
will
yeah,
encode, yeah, everything as an enum, and then
yeah.
you have
It would
specific
be,
ways to encode and decode every single.
yeah, every single enum.
Mm-hmm.
Yes, you're right. So this enum will be API versions,
Mm-hmm.
and then it will have 4 fields that are API key, minor version, maximum version, and throttle time millisecond. If throttle time millisecond is not in all responses, in that case, if it's in all responses, it can go one level above,
Yeah.
right?
I'm not sure I'm following your last point, but yeah, we can try to write some code for this. So basically, what we want to do, let me refresh from here. So here we are reading, we have the API key in the request, right?
Yeah, we have the API key. Now we have to create the response that we have to give back. Now also needs a body. The body will be of type enum of all the possible bodies. For now, what I'm saying, we cannot make the enum now, and we can just say that the body is of type API version. Done.
Okay.
Or optional API version.
But the body, you think it's just gonna be in like, well, here we can just do whatever
There, in line
body.
38, body of type. In theory, we should do the enum of all possible answers.
Mm-hmm. Well, we
Now
can
you
do a
can,
simple enum, right?
with just
With just one.
one option. Yeah.
Yeah. So
And this one is called API version, was called.
versions, I think.
Yeah, and it will have 3 U16 and 1 U32
We
side
can give it specific.
names.
Yeah. So what
You
are
take in the
the
name
these two, right? These three.
those 3 and the throttle time a millisecond. I don't know if the throttle time is always there or is just
Yeah, this indentation is a bit confusing. Probably there is
yeah,
some
is
meaning to it.
I don't know what it means. I mean, there is or there can be multiple ones. I hope not. It means that there can be multiple versions. Let's try with only one version, then we take a look.
I'm wondering if this is like a spec that says there is always an error code, there is always an API key, there is always a throttle time MS. Then I'm just confused by this stack buffer here and
Me too.
this nesting here.
Let's try with just one object, not nested, and see how it goes. Let's think
Sounds
that is
good.
not nested.
Yeah, I'm only suspecting that here there is some kind of encoding. There is not
Yeah,
just as
that we
simple
are going
as
to miss.
in 16, in 16, in 16, in 16, in 32.
Maybe.
I think here this is some kind of wrapper that needs its own encoding.
Maybe, but I would like to try without it to see if there is any error that it gives us.
Mm-hmm. But from our own perspective, I think we can just do this, right? And
Yeah.
do
The throttle time in millisecond is Do you want to add it as another feed there, or after the max version?
Good point.
For now, yes, we only have one enum. I mean, it's not a lot of code duplication.
What is it? Throttle time ms int 32.
Now, in our match, in our stream code down in the main, or in the 2 bytes also, we have to expand here.
Yeah, we probably want to do a 2 bytes for this.
Yeah.
Sorry, implement response body, and then we do fn 2 bytes self, and it gives us a vec u8, and basically we only have one match, right?
Yeah. Okay,
Let's
sense.
just take all of this, which probably makes some sense.
Yes, seems so to me. And if he's wrong, we have to work here to implement the protocol.
Okay. So, and now here what we want to do is buff extend from slice, right?
Yes.
And then finally here we need to come up with a body.
We can add an enum with an empty body, maybe also. Oh, well, let's not do that now. In theory, here we should check if the request headers API key is 18 and the version is 4.
Exactly. Otherwise, we would need to send an error.
We are already checking the error code and setting it. If it's not 0 to 4. Now we have
But
to
this
check
is
the
just the
API
version,
key.
right?
Yeah, that is the API version. We need to check the API key, the request API key. That should be 18. Because if it's 18, we know what to do. If it is something else, we can send back an empty body. We can send back nothing. Don't know.
Fair
We
enough.
panic. So here we can do a switch on top of a request API key.
Rec, what did we call it? Rec headers.
Headers dot request API key equal 18. It was 18, right? Or I'm seeing a
Let's
random
just
number.
say
Okay, if it's different from 18.
was 18? I don't remember. Let's check that. 18.
18.
Good memory. So let's probably encode that somewhere. How do we do that? Let's just do it here. Const API key API versions. Thank you, Copilot. That makes sense. So if it's not that, then we respond with an error, right?
We set the error code to, I don't know what. We already set the error code in line 100. We can make it mutable and change it here.
Or should it be something like this, probably? Like if rec headers request API version. How do we do an in statement? So 0 dot equal 4 Is it includes? No. Contains that. So if it doesn't do that, then we error in a way. If it doesn't do that, we error in another way.
Okay, we can leave
And
that
then
for
here with the
later.
error code is just 0.
Okay. Now we have to add the body there.
Yes.
Line 117, we have to add the body. We can hard code the body for now.
Why it doesn't like that? Okay. And this one needs to have a reference. Makes sense. Now here a body is what?
After the headers, not inside the headers, after the
You're
headers.
right.
Body here is an enum of type response API version. Okay. Makes sense.
Why API key versions?
Because Kafka is sending back the same API key of the request.
Okay.
Maybe to be sure that you're answering the right stuff. I have no idea how they thought about this. I mean, I ask you the version, just give me the version. No, they give you, because like you said before, that is a semantic language that they defined. So in the response, they also tell you, look, 0 to 4, this is the API version. So in an highly concurrent client, you don't have to correlate the request with the response. Because in the response, you always have also what was the request, basically.
Yes, okay, fair enough. So
let's see what happens. I have not a lot of.
Yeah, I don't have a lot of
think
confidence that this is good.
No,
And
me neither,
also-
but it's a
Yeah.
try.
So we can run. How do we run this?
CodeCrafter test.
They
I don't
didn't
think there
even
is.
give us the.
No, I don't think
local thing.
they give you instruction to use the echo like in the exercises before.
So you can run your program, but yeah, they will do whatever. Okay, so if we do CodeCrafters test, let's see what does it do. Again, come on. I don't understand why they need this up front. Do they just do a commit every time we do a test?
I think so.
Oh, because they're testing it remotely. Okay, fair enough.
Yeah.
Okay, so there is an error, somewhat descriptive.
The length. We have to adapt the length.
Fair enough.
They told
Okay.
you that the length can't be 0 anymore. It's written in the instruction. Now we have to compute the length and add the right length.
Expected integer length to be 4 bytes. Got 0 bytes. Yes, well, the error is a bit weird.
Yeah, it's strange, but.
Okay, so how do we add that?
I just hope that not all of this should be coded in zigzag encoding. We'll find out.
So
Where do we set the length? We set it to 0 at the moment. It's coded somewhere in the 2 bytes.
We set it to 0 in the somewhere
Bytes.
here.
Yeah. Now, when we are before returning the buffer in line 77, between 77 and 78, because buffer is mutable, we can change the first 4 bytes to the length of the buffer itself.
We can change the first 4. Oh, I see what you mean. That's smart. So what we can
It's already
do...
mutable. We don't have to make it mutable, so fine. There is
So
a
we can
buffer overwrite. I don't know. We can go byte by byte. Is not. Yeah. Dot for
look at
copy
that.
from slice. The length as U32 to big endian bytes. Yeah. That.
Okay, but the length is excluding the first 4 bytes?
Ah, who knows? Including or excluding? No idea.
I would expect it's excluding. Like I would have here like a -4.
Some protocols included, some protocols excluded. So it's not an hard rule.
Okay, let's
Depends
try
on the
both.
implementation. But I think you need some brackets.
Let's make it happen. So that -4. Is that okay?
Complaining about buffer. Not borrow as immutable because it's borrowed as mutable.
Okay.
I can't read the length of buffer. Ah, you have to do that in another line.
Does that make it happen? And now we can just say, actually, we can even do -4 here if we want to. And now we can just say copy from slice, len.
Okay, now it seems happy.
Let's try again. I expect a different error now. Okay, different error.
Okay. I can't read it yet.
Sorry, let me make it bigger.
Okay. Byte 11 to 15. Unexpected end of date. Response, body, tag buffer, tagged field array, and signed variant. Yeah, we have to send a tag buffer, and we are not. So he's trying to read more bytes than we send.
Also, why is V3 and not V4? I thought they said it would always be V4.
Yeah, sending API version v4 request correlation ID whatever. Accepted new connection received, and then it tells you that the bytes between 11 and 15 unexpected end of data in the context of API version v3. Thank you. Request body tag buffer. Yeah, we have to find out how to encode the tag buffer and add the tag buffer at the end of those three EU16. You know, there is the EU16 and then the tag buffer. We have to send them.
Yeah.
And also send them at the end of the packet itself. But I think we can do this next time. We
I
are
think so. I'm
we
just
made
curious.
we made some progress.
I'm just curious to do this. So they were saying if you put the bug through here, you probably see more details. Let's see if it's any useful. There is a bit more stuff.
It's dump of the API request. Okay, the request, who cares, I would say.
And this is the response we sent.
And that is the response that we send. That is 16 bytes. Because you removed 4. Try to remove that -4.
That -4, what do you mean?
The -4 you put in the length.
To remove it?
Yeah, try to remove the -4. And see what happens.
It's different. Unexpected end of file.
No, it was better with the -4.
Yeah, I think it's trying to read 4 extra bytes.
He's
that are not
trying
there.
to read 4 extra bytes. Oh, well. We try. Okay, so the length is -4. We don't send all the. We need to encode that stuff. We need to encode that tag buffer. Otherwise, it's not able to read it, and that will make our length longer.
Sounds good. So shall we leave it at that and figure it out next time?
Yeah, I think we need to read a little bit of documentation and come prepared to next time. Let's wrap
Okay.
it up then. So you can find the recording on YouTube. The link is on Twitch in the About section. If you're watching this on YouTube, we do live streaming on Twitch every Monday at 6 p.m. Dublin time. Make sure to check the Twitch link in the YouTube description and give us a follow so you can be notified. Feel free to leave comments of any kind. Everything is well accepted. We are trying to learn Rust, so don't expect our solution to be the cleanest or more idiomatic ones. If you know better ways of doing stuff, let us know. Anything else? Do we write somebody or no?
Nope.
Nope. Nope. Nope. Okay, so see you.